So we're going to solve log expressions, and log expressions are going to be solved by doing exponentials. Year doesn't count. Log expressions are going to be solved by using the exponential of it, right? That's because log and exponential are inverses of each other. That's what property numbers 1 and property numbers 2 of our notes told us, is that they are inverses of one another. So we're going to rewrite with one term on each side. So you want to make sure that your log with variable is by itself. Okay, so we want to make sure the log with the variable is by itself. Then we're going to take the exponential function of the same base on both sides of the equation to undo the log function. That's our properties number 1 / number 2. So if I have log base 2, that means I'm going to raise it to the second power. If I have the common log, that means I'm raising it to the 10th power. So then we're going to solve, and we're going to use inverse operations, inverse ops. And we're going to model it algebraically and graphically. The stuff in the red is totally optional to write. It's just what I'm telling you. So you do not have to write it unless you want to. All right, so we're gonna get started. So for this example, there's more than one way of solving this, okay? We can solve it by making 3 a power, or we can solve it by dividing by 3, okay? To me, it seems that the easiest way of doing it is to make 3 a power maybe and see what happens. But again, you can also divide by 3 and go from there. So I may just model both. All right. So first step here is to use property, because number 1, property number 5, and turn 3 into a power. Now, because 3 is becoming a power, it's going to affect the 2 and the x. So that leaves us with log, what's 2 to the 3rd? X to the 3rd equals 4. And that gives us log 8x to the 3rd equals 4. Okay, so now our log is completely by itself. So step 2 is to now take the base and raise the function to the base. So my base is invisible, but it's a 10, right? So I'm going to raise this to the 10 and raise this to the 10, which is property number 1. So because it's raised to the power, it's raised to the base of the log. These are going to cancel each other out. And we're left with 8x to the 3rd equals 4. A 10 to the 4, not just 4. Missing some numbers there, guys. 10 to the 4th. Okay, so here, what would you do to get x by itself? Move stuff around. Oh, okay, good call, good call. So what we're gonna do is we're gonna divide by 8, agreed? So we get x cubed equals 10 to the 4th divided by 8. How do you cancel out a cube? We're on step 3, I'm sorry. How do we cancel out a cube? No, we take the cube root is what she meant to say. So you take the cube root of the numerator and the cube root of the denominator. And that is x equals, when you're taking the cube root of variables, that just means you are, anyone remember? What does that mean is happening? You're just writing as a power, right? So that just becomes 10 to the 4/3. And what's the cube root of 8? What number times itself? 2. So this is our exact answer, this guy right here. So that's our exact. So then to find the approximate, we're going to plug it into the calculator. So we're gonna go to handy dandy calculator. I can't stand it. All right, I'm gonna clear all. Clear all. So we have 10 to the what? 4/3 divided by 2. And then we hit enter and we get approximately 10.772.
Oh, this, okay.
The answer?
No.
Well, the process?
Yeah.
Yes. So we get 10.772. And then step 4 is to check yourself. If I plug this back into the original, do I get 4? And the answer is yes. The beauty about using a calculator is you can copy and paste, right? So if I wanted to check myself, I would type in 3 log parentheses 2 times, and I can copy and paste this. So I'm going to copy and I'm going to Control V. And do I get 4 as my answer? Yes. So what does that tell me? I did it right. Bam, got it. Answer is 4. All right. Now, what I wanted to tell you is that, remember I told you there's more than one way of going by this problem. So I'm just going to do it really quick and really fast in this little space right here. So if you chose to divide 3 first, so you would have been left with log . I don't know why I just closed out on me. You would have been left with log of 2x equals 4 divided by 3. Then you would have taken the 10, canceled out, and you would have been left with 2x equals 10 to the 4/3 divided by 2. And is that not what we did? We went through all this to get. Yeah, right? So in essence, isn't it better to kind of just move everything away from the log and then proceed? If not, could you go through this route? And we're still ended up in the same boat, right? Do we see that? So just wanted to throw that out there. All right, so let's do it number 2. So number 2 is the log by itself. Yes, good to go. So step 2 is you're going to raise it to the power of the base. Well, the value of the base. So if there's no base there, then what is it? 10. So we're going to raise each side to the 10 to that power. What happens with the log and the 10? They cancel because they are inverses of each other. So we're left with 4x plus 10 equals 10 to the 3rd. What is 10 to the 3rd? Well, that means you have 10 times 10 times 10. What is 10 times 10 times 10? 1,000. 1,000. It's 1,000.
Are you recording?
Yes. So step 3. What do we need to do to get x by itself? What do we need to do to get x by itself? Move what? What's the first thing I need to do to get x by itself? Subtract 10. So we have 4x equals 990. Nope. Raw footage. All right. Now what do I do? Now I divide by 4. So let's do some shorthand division. 4 goes into 9 how many times? With the remainder of 1, right? 4 goes into 19 how many times? 4, right? Because 4 times 4 is 16. So it goes in there 4 times with a remainder of 3. 4 goes into 30 how many times? Where y'all multiplication skills at, guys? 7 goes in there 7 times. And there's nothing else. So there's a remainder of 2. So it's 2 out of 4. And look, we just did shorthand division. So 247 and a half. That's what your X equals. Exactly.
Ms. Jones.
Who taught me shorthand division? My 4th grade math, my 4th grade teacher.
Ms. Jones. Ms. Jones,
Was it he?
can you please mute that video?
All right. So then step 4 is to check yourself. And so if I wasn't very confident with my answer, what should I do? Check it, plug it back in. So I'm going to go to the calculator and type it in. Log parentheses 4 times 247.5. What was it? Plus 10? Plus 10. Does it equal 3? Yes, you're a genius. Good job. All right. So that's all 4 is saying, is that it's an equation. And the beauty about equations is that you can check yourself. All right. Now, examples 1 and 2 are what we consider simple because they only have 1 log in them. Right? Now, if you look at 3 and 4, examples 3 and 4, there's more than 1 log in each one of them. For some reason, again, PowerPoint decides to renumber my problems every single time. I don't know why. All right, so on problem number 3, we need to condense this down to 1 log, okay? And we're gonna do that by using property number 4. When you're subtracting 2 logs, how can you combine them to 1 log? That was on 7.6 notes. How did we combine? Subtraction led to division, Miss Jones. Subtraction leads to division. So that means it becomes log of x plus 9 divided by x equals 3. Okay, so we use property number 4. And now we're on step 2. Step 2, we're going to use property number 1, which says we're going to raise this to the 10th. But this will 10 to the log. And what happens when we raise it to the 10? It cancels out. So we're just left with x plus 9 over x equals. And what did we say 10 to the 3rd equal? 1,000. Right? Okay, so step 3 is to solve for x. So going back to our algebra skills, what do we need to do to start solving for x? Thank you for stating the obvious. Yes, we need to move some stuff around. What do we need to move first? The x in the denominator. Before you do anything, you got to move the x in the denominator. So we have to multiply. And what I do to one side, I do to the other. So this cancels out, and we're left with x plus 9 equals 1,000x. Now what do we do? That's what you should do. You're going to combine your like term. So you're going to subtract 1x. If you have $1,000 and you spend $1, what are you left with? 999. All right, then what's the last thing we do? Divide. And what does that reduce to? It reduces to 1 over 111. 11.
Okay, that's good. We don't need to check the next problem.
So you don't need to check? You believe in yourself?
Yep.
All right, so feeling pretty confident.
What does that mean?
Okay. All right, so you know how they say there's more than one way of doing things? There is. Number 4, there's a lot of ways to do example number 4. Not a lot, there's like 3, but that seems like a lot mathematically. So how do you want to do? If you were looking at this, you're like, oh my gosh, what would you want to do first? property number 5, right? So number 1, I'm going to use property number 5. Property number 5 allows me to do this guy, right? Take my powers, then take my coefficients and turn them into powers. So we have log 4 squared minus log 3 plus log x squared minus 4 equals 0. Okay, my job is to combine them to one log. When you're combining, when you're condensing, you want to work from left to right. Does that make sense? So from left to right, I have 4 squared minus 3. So in terms of log, this is still number 1. In terms of log, I'm going to use properties number 3 and number 4. Number 4 is for subtraction. Number 3 is for addition. Okay. This guy right here, he needs to go away because does he even have a log? No. So he's being shipped to the other side of town. So we're going to work it from left to right. So we have log of 4 squared divided by 3 times x squared equals 4. So subtraction became what? Division, and addition became multiplication. And why did we move the 4? Because it didn't have a log. Now I have one log. So now I can go to step 2. In step 2, I'm doing what? Raising it to the base, right? And what is our base? 10. So we're going to raise to the 10th power. And what I do to one side, I have to do to the other. So what happens to the log and the 10? Cancels out. And we're left with 4. Can I just write 16? Is that okay? Everyone understands that 4 squared is 16. Just making sure. Just making sure. Just making sure. What is 10 to the 4th power?
Don't be putting me on the hot spot like this.
It was the answer you said the first time. There you go. There you go.
That was just a minor mistake, you know, Jesus made a mistake typing Albert Einstein together.
I don't know how to respond to that, so I'm just going to keep going. All right. So how do I get x by itself? Multiply by the what? Starts with R. Reciprocal. So we have 3 over 16. Cancels out on this side, and we're going to multiply 3 over 16. So we're left with x squared equals 30,000 over 16. I'm just making sure you know. 3 times 10, I got that. I'm good.
Don't do that.
I'm good. All right. And then what's the last thing to get x by itself? The square root. So we're going to get x equals the square root of 30,000 divided by 4. What is that? Calculator peeps. Do we know why I wrote 4 instead of 16? Okay. Why? I square root. Perfect.
So if you keep 16 in there, it's gonna be wrong.
As long as you put the entire thing under the square root, no. Yeah. So the square root of 30,000 divided by 4, I'm going to go. So square root 30,000 divided by 4, hit enter, and I get 43.301. Now, if you wanted to do the whole thing, you would have to put the square root, and then you would have written 30,000 divided by 16. So as long as it's all underneath the square root, then you're fine. So we get 43 and 301 10,000. We're around to the nearest 3 decimals.
All right, we're finishing tomorrow.
So we have x equals approximately 43,301. Approximately. Those are my approximation numbers. And again, if I didn't feel comfortable, what would I need to do? Check it. Now that's a lot to plug back in. But so I feel pretty good about my answer.
Ms. Jones, what goes on page 148?
Your extra practice that we've been doing in our notes. All right, we're gonna at least do one of the real world problems. Okay, so we have the enrollment at a private school was initially 120 students and has been increasing by 30% each year. Formulate a logarithmic function t of x that approximates the number of years t it will take before the enrollment reaches x students. All right, so step one, we have to start with our, in order to get to the log, based on the information, we're gonna start our exponential. So we're gonna start our exponential function. And our exponential is the opposite of our log. So instead of t of x, it would be x of t. Because they're inverses of each other, right? Your independent and your dependent switch places. So we would have x of t. So our initial, it says initially you have 120 students. You're increasing. So you're increasing, which means that you have your 100% plus your 30%. Which equals 130%. And so as a decimal, what is 130%? 1.3. So that's our exponential model. All right, so now we want to find the log model. So to find our log model, we're just going to take the log. So our goal is to solve for t. So if we want to solve for t, we would have to take the log of both sides, right? So that would give us, well, we got to get t by itself. So in order to get it by itself, we need to move everything outside of the exponential. So what needs to be moved? 120. How do you move 120? It's multiplication. So the opposite of it is division. So we're dividing x by 120. So we have x divided by 120 equals 1.3 to the t. Now that my exponential is by itself, I can take the log of both sides. So that's going to give me the log of this one and the log of this. I'm just going to squeeze it in there. I'm going to get in where I fit in, right there. Okay. What the log does to the, what's this side? Right side is it allows our power to become our coefficient. So we have log of x divided by 120 equals t log of 1.3. Huh? Which part? This right here? The log? So the log part is property number 2. It tells us if we take the log, it allows us to free the exponential. So we use that, and that allowed us to free our exponential and use property number 5 to move it to the coefficient. And now we're here, and the goal is to get t by itself. So what would I need to do to get t by itself? This is multiplication, and the opposite of multiplication is divide. So divide by log 1.3. So now t is by itself. So our log model is t of x equals, what does division mean for exponentials? If I want to expand it, it becomes what? Subtraction. So it becomes log of x minus log of 120 divided by log of 1.3. And that's property number 4 that makes it expand. So now this would be your log model. Okay. Well, then we can go back over it tomorrow. You can ask questions so that hopefully it makes more sense. But it's a
Did you sign